Let's look at the procedures for the experiment, chemical bonding and conductivity. Turn to the very last page, almost the last page. Here are the procedures, and there's a data table. We demonstrated the first 3 compounds yesterday in class. Today you'll work on the next 15 compounds. Each group will be assigned to work with just 5 of them. At your bench you'll find a list of the ones that you'll use. Just follow the instructions for each of those 5 compounds. You'll find samples over on the supply table. There are some cups that you can label with the number for your sample so that you know which one you're doing and which one to get. Take the cups over and just put a little bit in. For example, if I were getting copper sulfate, one of the solids, I just need a tiny scoop. I don't need a whole lot. Now when you look at the instructions, some of them are going to ask you to put water in them. So pour yourself a nice clean cup of distilled water. This is pure water. And if you have to add any water to the samples because they're solids, then all you really need is a good squirt. Any of these samples that are already liquids, you don't have to add anything to. And at least one of your samples is going to need to be melted. So to melt the sample, put it in a test tube about 1/3 full, and then use a test tube holder. Just squeeze it to open it and hold it over the flame until it is melted into a liquid. And then when it's melted into a liquid, you can test it. When you're done, just put it back in the beaker and don't try to clean it out because it won't get clean. Now when you do the tests, you're going to use the conductivity tester. It's basically a 9-volt battery with a little circuitry. There's a resistor on here to keep the battery from blowing out the little tiny light bulb that's in there. And test to make sure that it works by touching the wire ends to something that's metal. The wire ends, where's my camera here? The wire ends, there's just 2 little wires, and you want to make sure that they're not touching each other, because when they touch each other, then that closes the circuit and then the light bulb goes on. And what we want to do is put things between the wires that conduct a current. So like this paper clip here, if I put something metal between the wires, then the light bulb goes on. There we go. I can hold it with one hand. There we go. So when you can test it to make sure that it works by putting something metal between the wires. Also test to make sure that the wires are clean by dipping them in the water. When you dip, only dip the tips, just the tippy tips, because we don't want to get anything stuck up in the plastic part of the wire. Now as I dip this in the water, the light does not come on, which means that my wires are clean and are ready to use for testing. Each time you do a test, make sure to wipe clean the wires using a paper towel. Make sure that the wires aren't touching each other and dip them to make sure that they're clean. The light should not go on if they're clean. And then when you dip into the sample that you're testing, look to see if the light goes on. If it does go on, then you want to record that the material is a good conductor. If it doesn't go on, then you want to record that it's a non-conductor. If the light kind of is very, very, very dim, almost not visible, but you can see that it's trying to turn on, then we can record that one as a poor conductor. And up on the screen we'll put all of our results so that we can compare, and any ones that we don't have agreement on, we'll have a little test on the screen for everyone to see. When you're all done, please make sure to cover your flame. You can dump out the water and you can throw away the cups in the garbage. Don't throw away the test tubes. I'll take care of those. All right. Okay, if you didn't get a chance to see the results in class and try them yourself, you can watch this little demonstration here. First thing I'm going to do is make sure that my conductivity tester is working by taking a piece of metal and touching the 2 wires of the conductivity tester together to the wire. And okay, so the light comes on. The wire that the paperclip is made out of is metal, and metals are good conductors of electricity in their solid form. I'll also check to make sure that the water that I use to make my mixtures is pure. When I dip the wires into the water, the light doesn't come on. That means that when I use this water to mix some of the solid materials to make mixtures, that water is not a conductor. Any result that I see of conductivity comes from the material dissolving in that water. Okay, so I'll go right down the list of materials that were tested. Substance number 1, potassium iodide. When I dip the wires in, the light comes on, so I would record that it was a good conductor of electricity. And then I'll wipe my wires clean and make sure that they're clean by dipping them in the water and testing. The light doesn't come on. Good. Then I'll test number 2. Number 2 is magnesium sulfate. The light comes on, meaning that that's a good conductor. I'll wipe off my wires, dip and clean. Then I'll test number 3. Okay, that one's a good conductor. That was monocalcium phosphate. Number 4, zinc nitrate, a good conductor. Okay, so right down the line so far, all good conductors. Number 5, sodium aluminum phosphate, good conductor. Okay, we're on a roll here. Number 6, copper sulfate, good conductor. Alright, those are all solid materials that were dissolved in water. The water itself is not a conductor, you can see, because when I put the wires in the water, no light comes on. Now number 7, urea, that one is a solid that melts at a low temperature, so I've got it over here. I'll dip the wires in the beaker on the hot plate here, and nothing happens. The light doesn't turn on, so urea, not a good conductor of electricity. That's a result that we haven't seen yet. I'll wipe the wires clean. Number 8 is sucrose. That's table sugar. That's bubbling over here on the hot plate, so I'm going to dip the wires in, and we'll see what happens there. Okay, I see no light turning on. Alright, so that's a non-conductor result. Now there's a bunch of goop on my wires. I'm going to have to clean that off. Make sure that the wires get nice and clean before I resume my tests. Okay. Well, it looks like I got a bunch of junk on there. I'm going to have to cut these wires and get some clean wires to go on to the next test. So just hold on. Okay, I cut myself some fresh new wires. Now there's no goop on them anymore. So that was sucrose. We found that was a non-conductor. Now we'll continue on. Number 9 back here, this is vegetable oil. Dip the wires in. No light goes on. Okay, so that's a non-conductor. Clean off my wires. Oops, the light came on there because I touched the wires together. Make sure that they're clean. Number 10, ethanol. That's right here. Okay, no light coming on, so that's a non-conductor. Number 11, glycerin, over here. Okay, we've got no light coming on, so glycerin's a non-conductor. Number 12 is wax. Wax is melted back here on the hot plate, so I'll dip the wires in there, and we'll see if wax, nope, no conductivity, no light bulb coming on. Wipe off the wax. Okay, number 13, ascorbic acid, that's vitamin C. I dropped a vitamin C tablet into this cup, and the light comes on. That's a good conductor. Okay, wipe that off. Number 14, acetic acid, that's vinegar. Good conductor. And finally, number 15, citric acid, sour flavor. Alright, good conductor again. So those are the 15 results. We'll take a look at those results and some things to think about when answering the questions. Let's take a look at our data. The first 3 compounds I tested in class as a demonstration. We observed that water was a non-conductor of electricity. Sodium hydrogen carbonate, or baking soda, when added to water, makes water conduct electricity, a good conductor. Sodium chlorate, a solid, when melted, is a good conductor of electricity. Back at the lab bench, groups tested 15 more compounds, and I demonstrated that potassium iodide was a good conductor, magnesium sulfate was a good conductor, monocalcium phosphate, a good conductor, zinc nitrate, a good conductor, sodium aluminum phosphate, good conductor, copper sulfate, good conductor. So a whole series of results, all good conductors. Looking at the next set of results, the next one, urea, was a non-conductor when melted. Sucrose, when melted, a non-conductor. Vegetable oil, already melted, a non-conductor. Ethanol, non-conductor. Glycerin, non-conductor. Wax, when melted, non-conductor. The last 3 are all acids, and they were good conductors. Some students in class observed that the ascorbic acid or vitamin C tablets may have been poor conductors. That could be because the tablets didn't completely dissolve before they were tested. But there is conductivity among those three acids. Now, as you go to work on answering the questions that follow, here are some things to make sure to do. One, make sure to read carefully the background section, which explains how you can test compounds to tell what kinds of bonds they contain. So if you look at this part of the packet, it'll explain what do the results mean and what kinds of chemical bonds are indicated when the light goes on or doesn't go on in the test. The other thing that you want to do is, when you look at the formulas for the compounds, look at the elements that the compounds are made out of, and you want to select just the elements that are metals. To find out which ones are metals, look at the periodic table, which is on the back of the assignment, and find the elements that are on the left side of the stair-stepping line. There's a thin stair-stepping line there. The elements that are on the left side are metals. Sodium, potassium, magnesium, calcium, iron, copper, zinc, and aluminum. Those elements are all part of the chemical formulas of some of the compounds tested. One or two of the questions ask you to circle those elements when you find them in the chemical formulas and to look for a pattern in the conductivity results of the compounds that have metals in their formulas. One of the elements that's over on the metal side of the periodic table is not really considered to be a metal, and that's hydrogen. The reason it's over there with the group 1 metals is because it has one s electron in its valence electron orbital, like the other elements that are in that group. However, it reacts more like a nonmetal by gaining or sharing electrons in a chemical reaction. Sometimes, however, it does lose electrons in a reaction, similar to the way that metals react. And that's particularly found in some of the compounds that were tested. We'll see if you can figure out which ones those are, where hydrogen acts more like a metal than like a nonmetal. But by and large, when we're looking at which elements that are in these formulas, which elements are metals, do not consider hydrogen to be a metal in those chemical formulas. Focus on the main metals, sodium, potassium, magnesium, calcium, iron, copper, zinc, and aluminum. Some of the other elements that were part of the chemical formulas, the ones that are nonmetals, on the left side of the right side of the stair-stepping line, were carbon, nitrogen, oxygen, phosphorus, sulfur, chlorine, and iodine. Those elements were also part of the compounds in addition to hydrogen, but we'll not consider those to be metals. All right, so work on those questions, and if you need some assistance, please come and see me during homeroom.